Hey guys, welcome to 10.1b, Geometric Sequences. So we have what are called sequences in series. With a sequence, it's just going to be identifying a specific pattern, and we can find certain terms in that pattern. The first one is called geometric, and we're going to be using the same formula every time for this. Okay, so a geometric sequence is a sequence where each term changes at a constant multiple or a constant rate. And the common ratio, or the rate, is denoted by r. So we use r to represent the common ratio of change every time. So example 1 here, decide whether each sequence is geometric. Look at the first one. Notice we go from 4 to -8, then from -8 to 16, and then 16 to -32. So we're alternating each time by a negative value, because to go from positive to negative, that's what you're multiplying with. So notice that right away. And then we are getting bigger by 2 each time, because 4 times 2 gives you 8, 8 times 2 gives you 16, and so forth. So yes, and then we're going to note that r equals -2. Then we look at example B. We have 3, 9, and then we jump to a -27, then a -81. Now that's not consistent because we have to multiply by a consistent rate. There's no number that we can multiply by 3 to get +9, and then by 9 to get -27, and then back to another negative. So this one's just going to be a no. This next one here, note we have 5, 10, 20, 40, 80. So it's getting bigger each time. And it is getting bigger by a rate of 2. So we're multiplying times 2. So this is a yes. R equals 2. And then lastly here, now notice we're getting smaller. We're going from 12 to -6 to +3 to -1.5 to +0.75. So when it's alternating, usually these work out, but we have to figure out what the r is going to be that makes it consistent. And if you notice, it's almost like we're dividing here because it's going from 12 to -6. So we could think of that as dividing by -2, and then -6 divided by -2 would be +3. But it's actually going to be r equals -1/2. Multiplying or dividing by 2 is the same as multiplying by a half. So that's just something you have to get comfortable with, multiplying by fractions. Now the trick, just off to the side here, if it's geometric, so if we are multiplying and you are struggling to figure out the number, the rate, you can always do this. Your second term divided by your first term. So if we look back at like part D here, if we did 12 divided by -6, we do in fact get -2. If you can determine that it is geometric, this process will work every time. Oh, I did that backwards, sorry. It should have been -6 over 12, which would have been -1/2, which is what we got. All right, example 2. Rule for an nth term of a geometric sequence. The nth term of a geometric sequence with first term a of 1 and common ratio of r is given by this formula. A of n equals a of 1 times r to the n minus 1. So we want to write a rule for the nth term of this sequence. Whenever we do this, the first thing that we want to notice is what is the first number in the sequence, because that's part of our equation, which is going to be this 2 here. And then the rate, how do we go from 2 to 6, 6 to 18, 18 to 54? Hopefully you noticed that it's just multiplying by 3. All right, so now that we have that, we can write the equation. So it's a sub n equals a of 1 is 2, r is 3, to the n minus 1 power. And this actually should look really familiar because this formula is similar to what we were talking about where we had exponential growth functions and we were writing those equations in the last unit. Then it says find a of 8. So we want to find the 8th term in the sequence. So to do that, we are going to write out our formula, but instead of n, we're going to put 8 in place of that. So it's going to be 2 times 3 to the 7th power, and that ends up equaling 4,374. You could type that in your calculator. All right, let's do another one like that. So we want to find the nth term of this sequence. So first, we off to the side here, let's think about what is the first term in the sequence. Again, it's positive 2. And then the r, now notice we're alternating, so we're going from positive to negative to positive to negative. So that should give you an indication that it's going to be a negative number. And then to get from 2 to 4, we'd multiply by 2, 4 to 8, multiply by 2. So the rate's going to be negative 2. So then what we do is we write it out. A of n equals a sub 1, 2 times negative 2 to the n minus 1 power. And then we want to find a sub 10, so 2, negative 2 to the 10 minus 1, which is 2 times negative 2 to the 9th power, which ends up being negative 1024. Okay, and then we'll do one more for good measure here. So this next one is, notice we're going down each time. So that means we're going to multiply by a fraction since it's getting smaller. So it's going to be a sub 1 equals 56, r equals, now we're going from 56 to 28. So remember that trick I showed before where you can take a of 2 divided by a of 1. So if we take the second term, 28, divide that by 56, this does actually reduce down to just 1/2. And the numbers, like the signs aren't changing, so it's a positive 1/2. So our formula is a of n equals 56 times 1/2 to the n minus 1 power. And then we want to find 7, so we plug that in. 7 minus 1. And we get 56 times 1/2 to the 6th power, which just ends up being, if you type this in your calculator, it's going to come out to be 0.875, or if you were to actually write it out by hand, it would end up being 7/8 after you simplify. So either of those answers would work. All right, just a few more here. Find the nth term given a term in the common ratio. One term of a geometric sequence is a sub 4 equals 3. The common ratio is 3. We want to write a rule for the nth term. So what we're going to do for this is we are going to think about how our equation would look. So we know that the fourth term in the sequence equals 3. We also know that r equals 3. And so if n equals, whenever you see this, n equals 4, because that's what the fourth term, a of 4, would be, then we could think of this as a of n equals 3. So this is the same thing as like a coordinate pair, because if we plug in 4, it's like our x, and then 3 is the output. So that's like the y. We're going to have to think of it like that. So then off to the side here, we're going to use our formula. A of n equals a of 1 r to the n minus 1. So we need to fill out what we know. So using this example here of 4 and 3, I'm going to replace that a of n with 3. A of 1, we don't know, that's what we're going to be solving for. And then r, we do know, that's this 3 here to the n minus 1. And n that we're using is 4, so 4 minus 1. So you get 3 equals a of 1 times 3 to the 3rd power, which is 27. So you get 3 equals a of 1 times 27. So we're going to divide both sides by 27 to solve for that a of 1. So a of 1 equals 3 over 27 is 1/9. So the final answer is going to be a of n equals, we want to write the general rule, 1/9 times 3 to the n minus 1. Okay, I'm going to do some more here. Now these ones are a little bit tougher because we're not given the r value right away. This one says two terms of a geometric sequence are a of 2 equals negative 4 and a of 6 equals negative 1024. And we want to write a rule for the nth term. So just like before, we want to think of these as coordinate pairs. So a of 2 equals negative 4 is the same thing as 2, negative 4. So think of that like a coordinate pair. We could do the same thing over here for the other one. A of 6 equals negative 1024. Think of that like 6 is the input, because that would be the n value, and then this is the output, negative 1024. And now what we're going to do is that same process that we did in the previous chapter. So we're going to write our formula. Remember, it's a of n equals a of 1 times r to the n minus 1 power. So a of n is going to be this as our output. That's the y value. It's going to be negative 4 equals a of 1 times r to the n power, which is 2, so 2 minus 1. You get negative 4 equals a of 1 times r. And just like before, we're going to solve for the a value, so we're going to divide by r. So that means a of 1 equals negative 4 over r. Now if we do that on the other side, with the other coordinate, it's going to be negative 1024 equals a of 1 times r, but this time it's going to be 6 minus 1, because 6 is the x value, or the n value in this case. So then we get 1024 equals, and now we're going to take this and we are going to substitute it in place of the a of 1. Negative 4 over r times r to the 5th, because 6 minus 1. Then you get negative 1024. We get negative 4. We have 1 r in the bottom, 5 on top, so that's going to leave us with 4 r's. We divide by negative 4, both sides. And we are going to get a nice number here. It's going to end up being positive 256 equals r to the 4th. So we take the 4th root of both sides. And you would end up, and you could use your calculator for this, but you end up getting 4. So now we have everything that we need. So off to the side here, I'm going to write the final equation. It's a of n equals, oh, I forgot to plug back in to get a of 1. So a of 1 would be negative 4 divided by 4, which would be negative 1. So it's negative 1 times 4 to the n minus 1 power, because we're just plugging it back in to this equation right here. Okay, let's do one more like that, just to be safe. So same thing, we're going to split this up into two sides. We want to fill out this equation. And this coordinate here, hopefully we're recognizing this is going to be 2 and 15. And this one here is going to be 5 and negative 405. So when we fill this in, it's going to be 15 equals a of 1 times 2 times r to the 2 minus 1. Then we get 15 equals a of 1 times r, divide by r. So 15 over r equals a of 1. Do the same thing over here. Negative 405 equals a of 1 times r to the 5 minus 1, which is going to end up being 4. But now we can replace this. Negative 405 equals 15 over r times r to the 4th, 5 minus 1. Negative 405 equals 15r cubed after we get rid of one of the r's. We're going to divide by 15. And we get negative 27 equals r cubed. And then to get rid of a cube, we take the cubed root, and notice we do get a perfect cube on the other side. So we get negative 3 equals r, and now we need to plug that in over here. So 15 divided by negative 3 equals negative 5, so that is the first term in the sequence, is negative 5. So a of n equals negative 5, or a of 1, times negative 3 to the n minus 1 power. And that's it for the note.